Okay, so uh, this is about problem-solving strategies. So how to solve problems. First of all, we need to define what a problem is. Problem is not the question in the exam. The things that you have in the exam are called questions, exam questions. Some people call it exam problems or homework problems, but that's not the case. Those are questions or assignments. What we have as a problem is a problem in real life that you are going to solve and make a solution so that people can benefit. But as a part of the education, engineering education, we use these problems, we simulate those problems in questions. We ask those questions to you as problems. So you can develop your problem solving skills. That's what we say, problem solving. And it's an interesting and fundamental topic. There are books on that. One of the books is given here. So there are many other books that contains the name problem solving strategies, problem solving. So what is problem solving? Here we have in the problem solving, we have analysis, design, development, and evaluation of problem solving. How to analyze the problem. What are the limitations? What do we have to do? What is the scope of the solution? And how am I going to make a design? How do I develop? How do I code it? And how do I know that, this is important, how do I know that that is the solution? Sometimes you start with problem A, and over the time, you come up with a solution B, which is not helping to solve the actual problem. Right? Mesela ÖTV gibi. ÖTV 99 depreminden sonra çıktı. İşte depremlere yardım edeceğiz diye. Ama that was a solution, which was a nice solution. But at the end, when we evaluate what it is, now it is not a solution for the original problem. This is my example is kind of funny example to make you understand, but it is also common, and it arises from miscommunication, and some people call it scope creep. Scope changes, focus changes, shifts. And one of the reasons of having the scope change, like in ÖTV, is you don't have written agreements on the topic. It's usually verbal. If you are making a project to a customer, okay? Say you are building a house. House building is very similar to computer software. You agreed upon with a müteahhit from Trabzon, right? Then he ends up with something very different than what you thought. What you were thinking that you will have a good villa, similar to what you see in American films, with the nice roof, etc. But he ends up with a gecekondu-like appearance. Functionally, it might be the same, but it is not the same thing. So it is shifted because it is not the solution to your problem. What was the misconduct here? You didn't write it. Okay, so design specification, what you want is not written, what you want is not defined. So it is verbal, vague, and not clear. So since it wasn't clear, it wasn't clearly defined, the output, the solution will be developed based on who? Based on the developer's experience. In that case, Trabzonlu müteahhit's background and the previous work will affect the output. It won't be what you want. So it is going to be different. So therefore, the evaluation is important and also design is important. And all of them are important in developing a solution. It is also the reason of making mistakes in exams. You are not idiot, right? I mean, you are all good students. But yet you make mistakes in exams. Yet you are studying hard, I know. Maybe 5% of you, okay, 5% of you is not working well. 5% of you may have family problems, friend problems, girlfriend, boyfriend problems, anything you can think of, all right? But the rest is working hard. So why do you make errors in exams? First thing is, you misunderstood. You don't understand the question. Second, what you think is different than what professor thinks. So professor envisions a case in the problem. If your mindset is not with him or her, you solve something different based on your experience, based on what you think. And it will be different than the original. It will be different than the original question. Then it will be graded as incorrect. Am I right? So same thing happens in construction, building constructions, politics, right? Economy, municipality works. They have renovated the lights in the intersection at the entrance of the school, right? Before the bus stops. They made a big mistake, but they didn't realize it yet. Part of the road is narrow before the lights. So when you are going to go straight back to Istanbul, you have to make a second line on the left as people who are going to turn left. But there are people waiting to turn to the right. The left turn light turns into green. The guys in front are waiting to turn to the right, and it is red for them. So you have to wait. You end up making a third line because you have to go straight, but that third line is the opposite traffic. So there are cars coming from that. So it's going to be a huge problem in coming days through the winter. Also, they tried to plant new trees which are not natural to the location, and they didn't make enough water drainage. When it rains, it's gonna be lake over there. So it was a good start, but the problem is not analyzed well. Since the problem is not analyzed well, I think the solution will be incorrect. Solution looks nice, a new intersection, lights, etc. But it's not realistic. It's not the solution of the problem. So software engineering is the engineering. Computer science is easy because you are not interested in money. You are living in a bohemian life. Your parents are giving your money, okay? Or you are a professor like us who is paid by the government. So whatever we come up with, we can live through. If I don't finish my research paper this month, I will still get my salary. But in real life, if you don't finish the project, you will be kicked out. So there are constraints. If you don't finish your project, you will be kicked out because, not because your boss is bad, because your boss is also making agreements with the customer, and he asked, we will be finishing your software in 4 months, so it's going to be ready before the Christmas, and your solution is not working. So this is engineering. There are constraints, there are time limits, there are budgets, and there is a problem. It's not computer science. It includes computer science, but it also has real life constraints like money and time, right? So it's a branch of computer science that deals with the design, development, testing, and maintenance too. Maintenance of the software applications. Software engineers apply engineering principles and knowledge of programming languages to build software solutions for end users. Believe me, it's very important, and in the age of artificial intelligence, it's more important because software is not going to be written by itself. Someone has to do it. Someone has to do it with the help of artificial intelligence, as you already learned. Do you understand? What? So it's planning, designing, development, testing, deployment, and maintenance. The famous principle kervan yolda düzülür or dizilir. Düzülmenin farklı anlamları var. Is interesting part because starting to a project may not end up with a good solution. You have to make plans. Planning, designing is much more important than doing it. Therefore, experienced engineers in all areas, politics too, economy, spend a lot of time in planning and design, then implementation. Inexperienced people jumps into implementation without any design. We work with several companies for consulting, and some of them I ask, what is the system architecture document? They look each other and they say, we don't have it. So I say, how did you write it? Ahmet wrote it, or something like that. So it's a big company, like a banks. And those projects are very difficult to maintain, very difficult to improve, and they will usually have performance problems because that only reflects the mental ideas of one original designer and build around it. Nobody thought that it might have a design problem or design flaw that limits the performance. You have to make design. You have to learn how to make design. So in the first stage, you initiate your design, initiate the need. Do I need something? What do I need? So it is project initiation. I will do it something like that. So we need something like this, that phase. Then phase 2, okay, I will do a chatbot. Chatbot, okay, chatbot. So what kind of chatbot? What do I need? So you need to write it down. Then for each function, how am I going to implement it before writing it? Then the phase 4, you start writing code or doing something. If it's a construction, building construction, if it is an economic policy or political thing, right? So that's important. Without phase 1, phase 2, phase 3, you cannot jump into phase 4. Is that clear? Politikada şimdi mesela süreç diyorlar ya. Phase 4. İlk 3 phase yok. So once you do it, you have to make sure that it is working. Then so when you are testing, you need to do 2 things. 1, make sure that it is working. 2, make sure that it is the thing that you wanted here. Sometimes it is not, and it is very interesting. What you end up is not doing what you want. And customer, it's a customer company relationship. Customer comes back, I didn't want this. So these are the functions I wanted, and they don't exist. You say, no, it is not. This is what you wanted, because there is no agreement, because there is no written agreement. It was all verbal. Everybody was happy in Cicimayları, right? At the beginning. And you shook hands, you go to the lunch, dinner together with the customer. Everybody was happy at the beginning. But after 1 year, at the time of delivery, people complain because everybody thinks that is not what I wanted. You have to write it down. For writing those functions and requirements, are important for 2 reasons. 1, it has a legal binding. I mean, if there is a dispute, you can go to court with the documents. 2, it's an analysis document to agree. You understand what customer says, and customer understand what it asks, so that it doesn't change, it doesn't add additional things. Since software or any system is a living thing, the additions never ends. So it keeps. It's like a house. The Trabzonlu müteahhit okay, delivers the house, and you say, but I want a chimney, okay, fireplace. Trabzonlu müteahhit says, you didn't ask for it. You say, it's a villa, it has to. So there is a disagreement. You think any villa in Istanbul should have a fireplace, but the Trabzonlu müteahhit says, what the heck? Make your own. I mean, I am not responsible from that. So those kind of additional requirements always comes. Therefore, writing down everything at the beginning to limit what needs to be done is very important. Unless you are doing research. If you are doing research, there is no limit. Sky is the limit. But nobody is paying. I mean, the deadline is the deadline of the conference. If that doesn't go through, there will be next conference. When I first established my company in 2013 in Gosp Technopark, all professors started companies because the school promoted that among the professors for entrepreneurship. Anyway, I got a project from a big company. We had 3 people at that time, 3 students. I was paying, like today, it was like 75,000 per month. They couldn't finish it on time. But I realized that I have to keep paying them. I have to pay their salary. If it was a student, if he or she, one of them was she, if they were students, I would give F, and they can repeat the class about the project. I can give an F. But they are my employees. I have to pay their salary. I have a responsibility. They also have responsibility. And if I delay the project, I will keep losing 200,000 Turkish liras per month. It's not like giving F. So, time, cost, and requirements are very important in software engineering because it's real engineering issue. It's actually all important in all areas, including social sciences, economics, politics, religion, etc. So you have to write it down to agreements. Otherwise, everybody thinks different. For that reason, for a long time, engineers are usually selected as politicians, managers, factory managers, ministers, etc. Because engineering discipline says, given the constraints, there are constraints, limitations, and resources. There is a need. You need to solve this problem with those constraints. You are not making a picture. So it's not an idealistic scenario. This is what you have. This is what you are going to do. It's not going to be perfect. Bedri Baykam'ı tanıyor musunuz? Ressam. Ressam Bedri Baykam bir ara önceki seçimlerde İstanbul Belediye Başkanı adayı olmuştu. Yani Tayyip Erdoğan'ın seçildiği dönemde galiba. Ressam adam yani. constraint falan benim kafama göre o mindset uygun değil. Şey de uygun değil mesela. Biriyle çalışıyoruz. Adam mimar. Bir software firmaları var. Dalıyor gidiyor başka yerlere. Şu yapılacak gidiyor. Orası önemli değil diyorsun. O oraya gidiyor gene. Onu seviyor çünkü. Bir şekilde götürüyorlar ama yani çok başarılı olmayabilir. Bize şeyi iyi, tabii ki alaylı olabilirsiniz. Tabii ki kimya bölümü mezun olup veya hukuk mezunu olup software'ci olabilirsiniz. Ama aynı olmuyor işte o. Yani o şeyi, constraint meselesini yapamıyorsunuz. So in reality, there is a start, request for proposal, you get the job, there will be requirement analysis, design, coding, testing, deployment, and support. Support is usually that's production support, the installation. Then after the delivery, you will also support the product with the updates, with the bug fixes or hardware. So in the warranty period, you have to support it. It's not like sell and leave. So when you are developing a product, also plan for the maintenance for software and hardware. When you are making a bathroom in a building or electric wiring, when you are designing it, plan how to change the light fixtures, how to repair the bathroom, how to change the pipes, how to renovate, how to make adjustments to certain structural parts of the building. If you don't pay attention to that, maintenance will be very difficult and require a lot of demolishing in software too. But if you make maintenance friendly design, then it will be easier. So, given a problem, how to approach? One thing is YKS miydi bizim sınavın son adı? So preparing for YKS is not a good way to prepare for YKS. So, it is very difficult way to learn something by solving the questions. You have to learn something first, then solve the problem. So solving problem is an inefficient way to learn how to solve problems, because you may keep doing the same mistake. Generally, analysis part is more important. You define the problem, identify causes, define the goals, identify strategies, take action, improve, and continue. So iteration. Not repetition, but iteration. This is one general approach. So you may not solve at the beginning. Your design may require multiple thinking. Onu yapay zekada bir şey çıkartıyor. Sonra onu input alıp tekrar kendi kendine input thinking modu var ya, çıkardığını bir daha düşünüyor. So that gives us some help describe the problem, describe the results we want, do some research. Birçoğumuzda bu şey yok. Hemen şöyle olur diyorsunuz. Anekdotal. Belki öyle değil. Kemal Bey dersteyim ama. Ben arayayım çıkınca. Tamam. Görüşürüz. Bye bye. So usually you start with anecdotal self-initiated solutions which could be wrong. You should at least open up Google, spend at least 5 minutes to see, is there anything like this on the topic similar to what I think. So at least 5 minutes, do some research. In final projects, for example, some of the students have very few references, scientific references, or some of them have no reference at all. I say, how did you come up with, I did it. So I did it is not the answer. You have to be aware of others in order to make a good solution. When you are making a building, you have to be aware of the building styles in United States, in Europe, in New Zealand, in Africa. That's what we call architect, Faculty of Architecture teaches that. So when they design a new, and if they didn't finish the school in cafeteria, if they really attended the classes, if the school is a good school, the product, the building they draw, the places they draw will be very good. But if we leave those drawings to the Trabzonlu müteahhit, it won't be as good because the scope is limited. Okay? Same thing is true for the software. You have to analyze what people are using, what is the language for it, what kind of database we need, what are the strategies for this type of problems in the literature, because you won't be the first one for that problem. At least there will be similar problems, not the same, but similar problems. The typical mistake is, for example, I am asking you to do improvised musical tune generator. So I tell you, go and do some research on improvised music tone generator. You go to Google, improvised music tone generator. The first 3 was advertisement, right? 4th, not interesting. 5th, not interesting, not related. That's it. So you come back, I couldn't find anything, sir. So that is not research, because the sentence you write may have different combinations. You may search related items, you may search different keywords that may be interesting to you, because there should be something close all the time. So don't come up with, there is nothing like this, and I am inventing it. No, it can't happen. Uzaylı bile gelecek olsa geçmişte gelme hikayeleri falan var yalan da olsa. En azından onlardan bahsedebilirsiniz. İşte şurada şu görülmüştü, burada bu görülmüştü falan diye. O bile yani şeyi var. İlk defa uzaydan uzaylı gelmiyor olabilir yani. In order to solve it, first ask yourself, do I understand it? Sınavda da buna dikkat edin. Ben bunu anladım mı? Burada tam olarak bu mu? Eğer o değilse başlamayın. Çünkü anlamadıysanız illa yanlış olacak. Two, would you be able to explain this question to someone else? So best way to reinforce your understanding is to explain it to somebody else. For us, professor says, one of my professors in university was, I am going to teach digital signal processing this semester. I want to learn the subject. He said he wanted to teach digital signal processing for the semester because he wanted to learn it. And that's true. As professors, if we are interested in a subject and if we want to learn more, we teach it because we have to get prepared. So as we are teaching, we also reinforce our understanding. It is extremely significant when I am teaching 151 because it is history of science. As I am being prepared and also as I am teaching, I realize, okay, that was the case. So you keep learning as you are teaching. 3, how many inputs? What are the variables that you can control? Do we need to separate out some modules or parts from the problem? Are they together? Is it a single problem or a problem with multiple parts? If possible, they can be separated. Do we have enough information to solve that question? Sometimes we don't. Bana bir chatbot yaz diyor. Gidiyorsun. Ollamayı kuruyorsun. Chatbot. Bu kadar mı diyor. Ama ben buna işte şey yazıyorum, cevap vermiyor diyor. İşte bir matematik sorusu sorunca. He, o zaman sen matematik sorularına cevap verecek lise öğretmenlerinin kullanacağı bir chatbot istiyorsun. Öğrencilere yardım için. O bilgi olmayınca senin doğru şeyi yapman imkansız. When you try to understand the problem, take some inputs and try to analyze the output. That is, so test with some variables. For this, it's going to work this way. For that, it's going to work this way. So this is a sample input and output. Taking some sample inputs will help you to understand the problem in a better way. But try to take it long enough or good enough. You will also get clarity that how many cases your code can handle and what all can be possible output or output range. By hand, consider some input. For example, for 0, what am I going to get? For 1, what am I going to get? For Ahmet Öztürk, Atatürk Caddesi, no one. So how it's going to work if it's an address? For credit card, just type some credit card number. Date, use some date. File, put a file. Consider some complex and bigger input, if possible. Don't type ASDF, type something longer with different characters. Consider the edge cases. For example, as you are giving the number, type -1, type 0, because 0 is associated with division by 0. -1 is sometimes also causing problem. So -1 backslash add symbol. So try to do, or 999999, a big number, bigger than unsigned integer. Unsigned integer 65.535 ya. 70.000 verirsen ne olacak? Geri dönüyor. Küçük bir sayı oluyor bu sefer. Okay, this is important. When we have a big problem, mesela şey yaptınız. Oyunu yaptınız değil mi? İlk başta zor gelmiştir size. Ya oha oyun yapıyoruz falan filan diye. Sonra bir görüntüyü oluşturma, screen layout için bir fonksiyon. Kimin nerede olduğunu tutmak için bir fonksiyon. User'ın input'unu almak için başka bir fonksiyon. Çarpıp çarpmadığını kontrol için başka bir fonksiyon düşündüğünüzde bunları birbirine ayırma ihtimaliniz var. Bunları sırayla çağıracaksınız. Şeyi bir ilerlet. Düşman gemilerinin bir sonraki şeyini çiz. Ateş etmeyi kontrol et. Onu bir ilerlet. Çarpışma var mı kontrol et. Bu şekilde ayırabilirsiniz. Ayırdığınızda biraz daha rahat olmaya başlar kafanızda. When you see the coding question that's complex or big, instead of being afraid and getting confused how to solve that question, break down the problem into smaller chunks and then try to solve each part of the problem. Bu önce fonksiyonları yazarak yapabilirsiniz. Şunu yap, şunu yap, şunu yap, şunu yap, şunu yap diye. Hatta komentlerle yazabilirsiniz. Önce bu yapılacak, sonra bu yapılacak, sonra bu yapılacak, sonra geri gidilecek falan. Tamam. Böyle mi? Böyle olacak. Böldüğünüz problemi fonksiyonlara. Sonra o ayrı fonksiyonları yapacaksınız. Öbür türlü yapamazsınız. Yani detaylarda boğulursunuz. So we call this top-down design. And I like it this way because that generally ends up with a complete working solution and finished solution. When some computing problems are object oriented and you are not good yet on the object oriented part, but basically it comes from this principle. When you break down the problem, you will think the problem in terms of objects, agents, different workers. So this object, some of them are documents, document object model, DOM. So document is an object. Document has functions. Document can draw itself, for example. Draw function is a member of document. Each document draws itself. So I have a list of documents. I can call draw function through the iteration. All documents appear on screen because each document knows how to draw itself, and it could be different for different documents. Depending on the document type, function could be different. Therefore, you divide each of them into different behavior. Yeah, the writing pseudocode, bu P ve S ve T ve S konusu, that's funny. One of them is tsunami, right? There was an earthquake in Japan. So you don't pronounce T in tsunami. People say tsunami. Here also, we don't say pseudocode, we say pseudocode. So pseudocode means verbal definitions of what's going to happen in the algorithm. And this became extremely important. Pay attention. This is extremely important if you are using artificial intelligence to write a code. Because when you give the pseudocode to the artificial intelligence engine, you can generate the code very successfully. Because that means you know the actual algorithm, you know what to do. You are not just interested in the language details, punctuations, etc. Okay, so actual construction can be done by AI, but the pseudocode will be written by you because you are the analyst for the moment. And we can't do in one shot. Therefore, give time for multiple iterations. As you are making your plans, always leave time for at least second version. Because first version will have problems, will have deficiencies, and you will not like it. You will realize that you can add additional stuff, or customer will ask, it's gonna crash, it's not gonna work, so you will have some changes. So make it iterative. What I like is top-down solutions. Top-down solutions are not interested in details at the beginning. Details emerge as you go through. Sometimes you have a bottom-up design. You are going to make a robot, which takes a lot of different parts. You will have a mechanics, electronics, vision, control, wireless, computation power, right? Intelligence, a lot of sensors. But you might be interested in, you may start with, for example, a robotic arm, whether you can do robotic arm movement correctly or not, or grabbing. You may start with implementing an arm, and if you are satisfied with the arm, you can move to implementing walking, because it requires a different set of abilities. Walking without upper body. Can I make a walking leg? Biped. So then you combine. That is bottom-up design. When the final product is not very well known, bottom-up is better. You don't know what to do. You are just wondering. Customer has some requirements, but it is not finished yet. Ultimate goal is known, but not clearly defined. Therefore, bottom-up is possible. In reality, it's combination of both. Some bottom-up, some top-down, and some reverse engineering. Look at the other products, look at the other houses, look at other software, other applications. If people are using certain approach and working, it's probably a good idea. So you can use it. And also use research tools. Scholar Google.com, Google, IEEE Explore, right? all the AI tools, don't just move by yourself. So this top-down design goes through the function concept. Let me go into detail. If you look at the problem as a whole, it could be impossible to do it because it is so complex, such as writing a text computation program or writing a word processor. It could be very difficult. Complex problems can be solved using top-down design, also known as stepwise refinement. We break down problem into parts, then break those parts into subparts. Then each part will be easy enough to finish. Functional decomposition. That is also good if you are preparing a dinner for your friends at house. If you are preparing for a dinner for your friends, you should first think about what should I have as a list, I think. Then do them separately. If you only start preparing one of them without thinking the whole dinner picture, you might be late because you are only spending your precious time on one of the things. It's not a good engineering practice. So starting from the top, going down, to me, is much clear. If you are going to solve inflation problem, economy, politics, okay? Think big, large scale, then identify sub-problems, make a list of those problems. I don't say forget them. Each sub-problem can be solved individually. Then it becomes possible. Or if you are government, for example, you can assign different people to each sub-problem. So each sub-problem will have managers. And in companies, bigger companies, software companies, those sub-problems can be given to different teams and different software managers. Then they combine the solution. The advantages are breaking the problem into parts help us to clarify what needs to be done, gives you the big picture. At each step of refinement, as you go down, new parts become less complicated and therefore easier to figure out. Part of the solution may turn out to be reusable also. Those smaller parts can be reused. Breaking the problem into parts allows more than one person to work on the solution as well. As I said, different parts can be developed by this functional decomposition or object-oriented decomposition, developed by different people. Şu arka taraftaki arkadaşlar bir şey yapıyor ama ben buradan rahatsız oluyorum. Buradan görüyorum yani ne yapabilirim. So like home redecoration, reconstruction company, painting, roofing, basement waterproofing, so doing everything. A section of town has recently flooded. We want to send out pamphlets to our customers in that area. So how do we do it? Get the customer list from file, sort the list according to zip code, make a new file of only the customers with the zip code. It's a database problem from the sorted customer list. Print envelope for each of the customers. Yani ilk başta firmamızda işte afet bölgesindeki insanlara mesaj göndereceğiz. Dosyayı açacağız. Zip kodu bulacağız. Zip kodla eşleştireceğiz. Database'den search edeceğiz. Zarfa bir şey yapacağız. So the thing, functional decomposition will be read the file, sort the file, select the file and print the file. Should any of these steps be broken down further? Maybe. If it is complicated, so functions, the primary functions can be decomposed into sub-functions. If it is, if you say I can write it, you don't need. But if you say, oh, it's complicated a little bit, if it is complicated a little bit, then if it is complicated a little bit, then you can subdivide further. When you functionally decompose, such as select zip code, open the file, or login the users, logging in the users, you can reuse it in other projects. So if you separate concerns, separate ideas, you can reuse your previous work again and again within the company and also with your project folder. So it also increases software reusability. Let's give a break for a while, then I will come back.
En alttayım zaten. Hep en altta ben varım. Bir soru mu? Bir soru dört puan. O soru yanlış. Şikayet edeceğim o zaman. Gelmiyor. Hatırlamıyorum ama. Genel. Hepsini unuttum. Hamza'ya kadar Sivas. Zaten o öyle anlatmıyor ki hikayeyi. Argo sorusunu geldi. Ya ben de orada olmak isterdim. Argo sorusunu.
Benim de telefonum bozuldu. Son yapamadım.
Benim de zevkli. Evet.
Tamam bak Muhammed Emin Yıldır'ı biliyorum.
Çok zevkli. Güzel bir atma. Ya da tam başka Deney yapacağız. Yapalım. Deney yapacağız. Koyuyoruz.
Bir şey söyleyebilir miyim? Katta bir ICT Huawei robotu var ya 23-24'te. O bir daha yapıldı mı?
Her sene yapılıyor.
Şu an yapılıyor değil mi? Biz onu duyurmaktan sorumluyuz. Huawei kampüs temsilcisi seçildim
Ne
ben.
olduğunu tam anlamadık.
Bize herhangi bir info atmadılar. Sadece duyurun diye attılar.
Anladım.
Ben de katta onu görünce siz biliyorsunuz.
Biz aslında Türkiye'de destek şeyi olduk. Biz Çin'e gittik geldik şeyle. BC. Şeydik de Kübra ile mi tanışıyorsunuz?
Kübra
Harput.
Bilgiç.
Kübra Harput.
Sen, evet.
Kübra Harput'la. Yani yarışmaya katılmanız gerekiyor ama siz birinci sınıfsınız. Biraz
Yok
bilgi
hayır
istiyor.
katılmak için değil.
Etkinlikleri şey yapmak için.
Duyurmak
Dersleri duyurmak için.
Sınav programı var sanırsam.
Ama önce dersleri almanız lazım.
Dersi
Dersleri
de
var.
vardır da.
Yani 23-24'e yetişemezsiniz aralığa. Yani üye oldunuz mu? Üyeliklerinizi benim onaylamam lazım.
Biz yarışmaya katılınca hocam.
Ama gene de üye oldunuz mu? Huawei Student şeyine üye oldunuz mu?
Ben
Portalda.
oldum. Ben kampüs temsilcisiyim şu an.
Ben bir şey değilim.
Ha, şeyden üye olun. Yukarıdaki QR kod gene çalışıyordur. O QR koddan üye olun. Bana düşsün. Orada dersler olacak. Alabileceğiniz dersler var. O dersleri şey yapacaksınız. Burada şeyimiz o. Öğrencilerin ekstra dersleri alması. Uzaktan eğitim dersleri var. O yani. Yani orada bir öğrenme süreci yaşaman
Sana
gerekiyor.
atılan şeyi açsana bir.
Yarışmalarda da çok adamlar çok bonkör aslında. Ben çok ilgilenemedim geçen seneden beri yurt dışına falan gittiğim için. Bir ara Türkiye'de biz birinciydik. Şey seçildik. Türkiye'nin Support Üniversitesi biz seçildik. Ayrıca sayfamız var. Hala sayfamız çalışıyor mu? Baksana. Huawei GTU Edu.tr var mı?
Bakayım.
Huawei.gtu Edu.tr.
Var.
Bunu böyle
Ha işte bu site var mesela. Bu sitenin eğer şeyini size verebilirim mesela yönetimini.
Atılan şey.
Bunu böyle bir post olarak mı paylaşalım o zaman?
Takvim var. 2026 için bu. Aynen.
Tabii canım o bu seneki bir
31
geçti yani.
Aralık'ta bitiyormuş kaydı. Böyle paylaşalım.
30 gün süreniz var demişti. Paylaşalım.
Yani gene çalışılabilir.
İşte Aralık başıydı. Tamam. Okey. Yukarıda şu işte. Okey. Bunu bir şekilde post yapalım. Aferin. Tamam hocam. Teşekkür ederim.
Teşekkürler hocam.
Okay. So, for the rest of your life, we will use top-down design for remaining programming projects. This is the standard way of writing programs and solving problems, top-down. So programs produced using this method, and only 3 kinds of control structures, like sequential, selection, and repetition, are called as structured programming. Structured programs, and this type of programming is called structured programming. Structured programming means sequential, do this, do this, do this, do this, do this is sequence. Selection, if then, else. Repetition, for. If then, else, for, and sequence makes you structured program. And you can use functions to make them hierarchical. And the top function is called as, in C programming language, main. Our top function is main, the program itself. Structured programs are easier to test, modify, and also easier for other programmers to understand. One idea. Write a program that draws this picture of a house. How do you do it? One interesting thing is there is a drawing line, drawing rectangle, and also painting rectangle. Color. Color is an attribute if it's rectangle. Furthermore, you have three identical windows. Three identical windows can be drawn by giving the coordinate and window as a description. So draw window here, draw window here, draw window here with the coordinates. So same function can be called 3 times with 3 different coordinates. Then you will have 3 pictures of the windows. So the idea is draw the outline of the house, draw chimney, draw door, draw the windows. So this will be functional decomposition. Otherwise, it will be difficult if you start painting like a painter. Even painters do it top down. They first draw the outlines of big objects, then they do details. So these functions, draw the windows, draw the draw the outline, can be solved individually. For the main, it will be like this. Our main call draw outline, call draw chimney, call draw door, call draw windows. So 3 function calls. Is it finished? No, because those functions are not described yet. So problem is not solved, but problem is outlined. In one of the years where I was giving microprocessors course, assembly language course, 50% of the grade was from the flowchart, 50% was from the code. And the question was sorting the numbers in an array. Sorting the numbers in an array in an assembly language. 50% was from the flowchart, so drawing what you are. The student did begin, sort the numbers, end. Okay? And obviously it was incorrect for the flowchart, and I gave 50 points. I gave like 10 points out of 50 for the flowchart. And he came back, Professor, I did flowchart fine, so why didn't you give me the full grade? So I said, you just repeat the name of the question. Begin, sort the numbers, end. So it's not the flowchart of the solution. He understood. So similarly, when you functionally decompose something, it has to be meaningful enough so that it contains some details. This is, for example, good. The door has both frame and a knob. We could break door into 2 steps. Draw door frame, draw door knob. So it could be, because knob could be complicated. You can give it to somebody else, your friend. You can say, your friend, can you please write the function that draws the knob? You are responsible from. You are starting the projects for the semester. So you have to decompose, you have to distribute jobs among you. So functional decomposition is kind of good way of giving people different tasks. This function is yours, this function is yours, this function is yours. But you have to agree on the interfaces, the function, what comes and goes, the variables. Draw door, therefore be draw door frame, draw door knob. And there are 3 windows. Draw window 1, draw window 2, draw window 3. So it will be called 3 times with different parameters. Last observation, as I said, windows are the same, so just call the same function 3 times without repeating the same steps over and over. The poor man's idea is simply copy the code 3 times or make it a loop, which is better. One story about exams. I was again asking something related to sorting, and the number of characters were like 100. And the student didn't use loop. He didn't use while loop or for loop. He instead tried to do it with if then else. So something like that. He said if array 1 is less than array 2, again if array 2 is less than array 3 is less than array 4, and apparently it will be 100. He put in the exam paper ... So my explanation is, if you are required to put ... in a solution in the exam, it is wrong. It is probably not the correct answer, because we don't ask anything that is not suitable for the exam paper. It fits to exam paper. Otherwise, we don't ask. If your solution requires ... that means it is not an algorithm. You are repeating too much. So what we expect you to develop an algorithm rather than repeating if A is less than B, B is less than C, C is less than D, ... Z. No, I don't want it. Okay? So loop is a good way of overcoming those problems, or while, or repeat. So draw windows function can internally repeat drawing window code 3 times in a for loop or while loop or whatever. So draw window location 1, draw window location 2, draw window location 3. So draw window function is only one function. You don't copy paste the code 3 times. Is that clear? In the case of draw windows function, we have to supplement the information with the 3 specific location each time we use the function. In our structure, we can add the information about the arguments to help document the design. We can also add return information, if any, in the design. Şuraya çizilecek, buraya koordinatı verilecek vesaire. In the design. So draw windows is a void. or it could be returning an error message if there is an error. Returning integers is a good thing. If there is an error, you can check by looking at the returned number in many cases. So draw a window with the location. Location goes, nothing comes. It is void. So main void return 0. Start with an empty code. Insert top functions. Then continue. Draw window. Draw a window. In this is not the definition. This is declaration because you have semicolon. Having those declarations allow you to think, okay, I will have this function, I will have this function. Now someone has to write inside. As you are developing your project, you can agree on these things, multiple of them, together in the meeting. Once you are agreed on them, everybody can go back their places and work on one of them. Because what you return and what you get is known. So internal behavior will be implemented by each developer. So you can have stubs. You can write those functions as empty shells. Stub. Do you know what stub is? Stub boş fonksiyon. Boş ya da yalancı. For example, if you are going to make a function that measures temperature from the sensor, but the sensor is not yet available or you didn't write it, just return 20 degrees all the time. So return 20. Measure temperature, return 20. So the other programs can keep using it except the temperature is incorrect. But it is working. We call it stub. For example, you are going to return the most successful student and GPA from database. Fine. Return most successful. Okay? Array name. If you didn't write it yet, return Ahmet Öztürk 4.0 all the time. It's fake, but it keeps the project running. Okay? It is called a stub. Then you can envision, you can understand how it is going to behave from the top. It's like making a web page, the main web page and the menus, etc. But the sub-menus are not yet presented, but the main menu and the main structure is available. Slowly, you will fill up the internals. Now we can say the program would really be more useful and give a better solution, the window drawing. If all of our functions were given in the location for each thing, that's going to be drawn. General solution, generalizable solution, is the best solution. Special solution is not a good solution because general solution can be reused. So, as good practice, we have to use top-down design. We use incremental programming using stubs. Make the curly braces, return, write the comments, and immediately write, because you will forget over the time, immediately make a comment, write, explain what you are going to do it there. Make notes, multiple lines. This function does, in English or in Turkish or in Tarzanian, whatever language. Write it, okay? Then start writing the code. Because you will forget what you agreed in the team. Yeah. So, 6 way to improve, this is from another place, 6 way to improve program solving strategies. Solve different problems on different platforms. Do it on Windows, do it on Linux, same thing. Do it on the web, do it locally. Do it with Python language, do it with C language. So, variety of ways of doing the same thing. 2, solve problems in different situations and contexts. Does it work in English? Does it work in Turkish? Learn from the past solves, apply them to new problems. So keep learning from your past experiences. 4, get help. That could be AI, other people, or Google. Don't work like middle-aged inventors. Only one person in a chateau, right? No. There are resources, there is a help, there is a community, okay? 5, solve problems regularly to keep problem solving part of your brain strong. Keep yourself intelligent, okay? 6, don't go drugs, etc. Actually, do you think drug is a problem in this university? Soru size. Cevap da bekliyoruz. Other universities, ben bilmiyorum, bilmediğim için soruyorum yani. Sessizlik olunca ne anlama geliyor?
Biz de bilmiyoruz.
Ha, siz de bilmiyorsunuz. Tamam, bilmediğinize göre yok anlamına mı geliyor?
İnşallah ama.
Tuvaletlerde falan şey görmüyorsunuz değil mi? Böyle baygın aygın tipler görmüyorsunuz. Yani şeyde falan var diyorlar ama bilmiyorum. Sabancı'da falan var diyorlar yani. Alkol de yoktur Allah bilir. Büyük ihtimal çok fazla. Türkiye'de zaten alkol şeyi fazla yok. Practice other skills that support good problem solving. Like critical thinking and communication. Bu teamwork ve benzeri çalışmalar da burada önem taşıyor. O yüzden bazı işlerde değişik skill'leri getiriyorlar. Bunun yanında böyle siz şimdi öğrencisiniz, hackathonlar, yarışmalar, arkadaşlarınız düzenliyor falan, etkinlikler, şu bu vesaire. Hepsi sizin problem çözme yeteneğinizi geliştiriyor. Bunlara soft skill diyorlar. Soft skill'ler çok önemli yeni dönemde. Aslında soft skill dedikleri problem solving techniques aslında. Yani aynı şey aslında yani. Hani böyle şak diye kalmayın diye bir şey karşınıza bir ciddi bir şey çıktığında kalmayın. Problemin altından girip üstünden çıkın. Olabilmesi için sizin eğitilmeniz lazım. Ve bu sadece computer science'da olmuyor. Problemlere yaklaşımınızla oluyor. Onu da cross disiplin şeylerle çözüyorsunuz. Bazen off-road'a gidiyorsunuz, bazen kampa gidiyorsunuz, olmadı yurt dışına gidiyorsunuz, parasız kalıyorsunuz, aç kalıyorsunuz vesaire. Bütün orada problemleri çözerken skill'leriniz gelişiyor. Bu önemli. Two more slides. Always try to improve your code. Don't let it go like that. Look back, analyze again, and try to find a better solution. Treat your code as something you make it better and better, like a sculpture. Look, change a little bit. Look, change a little bit. So it can improve. Explore the problem completely with all possible solutions and write down most efficient or optimized solution for your code. Sometimes the first algorithm is not the most efficient one, so you may want to change it later. Maybe you used bubble sort because it was easy to write it, but it is inefficient. You will see that. It is so inefficient, so you can use a quick sort instead and optimize your code. Make your code readable by other people. What else you can do it? What else you can make it portable across platforms? Like if you develop something for the iOS, can you port it to Android or Windows or Linux? So how can you make it more usable? So think about those solutions. I think the last word is make it simple, not simpler. Because when you are making something simpler, that means you are taking out features. Taking out features is not desired thing, but making it simple with the same functions is what we want. Okay. Anything else you can ask about how to solve problems in exams or in programming or engineering? Anything, any questions we can discuss? Okay. Was it helpful? Okay. So let me okay, some additional information about text input and output. You already know how to read and write from the files and the parameters. So this was the stream that I was talking last time. All devices were streams. The input-output is divided into multiple categories. Again, divide and conquer method. Subdivide the big problem into smaller problems so that you can understand each of them. First three is what you know. File open close, formatted input correct. The bottom ones are block reading for database that you did. So structure, binary read write. That is the file pointer, read, write, append. Position and the end of file marker, read mode from the beginning, write mode, and append mode. This is how we do it. You already know because of the lab advantage that we have. The additional things are scanf and printf are terminal input output. fscanf and fprintf are f. If starts with f, that's the for files. Same control structures available. These are the format specifiers. It's a good list for the printf or scanf. These are the types. We have hexadecimal and scientific GAE, which is less used. O for the octal. C for character, S for string. String is actually character of array of characters. Array of characters is string. There is a data type called string, but it is not a data type. It's a pointer to array of characters. Pointer is P. And yeah. So one error is, this is interesting. In the memory, you have 23 and space R. And you are reading it as digit. And therefore, B is read incorrectly. So instead, it is converted to ASCII. Integer value is taken, so it's gonna create a big problem. Therefore, C programming language is kind of a language for people who are careful. If you are careless, you will make errors. Since we have streams for everything in Unix and C language, streams should be flushed, and the flush empties the buffers. If anything is in the buffer, it is swept away to its direction. So flush sometimes necessary. We have the remaining bottom two scientific notations with E and G. The other ones are D, I, and U. You know that. Hex is for X. Real is F. You already know it. The examples. Okay, so in the print, we have formats. These formats could be right justified, left justified, padding, space for positive value, and no space for minus sign. So if there is minus sign and no minus sign, they will be aligned. So be even structures for that. You know this. So yeah. Append. What else? You will have this lecture notes. So these are just examples. Sometimes it's a good practice to name these as something meaningful, like IO result. So you check if IO result is end of file, return 0. So this is kind of, was there anything to read? No or yes. How many? Always program like mountaineers. Make a nail in the rock, tie yourself, and move. So always be safe. So if IO result, don't assume that there is something there. Don't assume that the file is there. File may not exist. So just opening the file and continuing won't work, because when you, after opening the file, check, is it opened? Does it exist? Okay. So those are the problem causes. Great calculation ABCD program. Similar to your homework. Input output characters. Well, get character, put character, get C, put C, F put C. Also pushback, there is an unget character. Get character, unget character. Put back is also available. Okay, let's move. Okay, now it's the binary. When working with databases, we use a binary access to read-write structures and images or whatever you want, music files. So these binary read-write uses block. It's a binary file. For example, the text 768A. 768 could be text. On the right, 768 is number. So it is actual integer number. A is also a character. So numbers could be different in binary file because numbers are actual numbers, not text. Text file store data as sequence of characters. Binary file store data as they are stored in memory. Memory copy gibi düşünün yani. File modes are generally the same. Read, write, append, read plus, write plus, append plus. Read edip write'e geçince edemeyebilirsin. Read'den write'e geçip tekrar read'e geçebilirsin. Bunlar da file pointer'ın state'leri. Yani her yapacağın iş yapılamayabilir. Onu sürekli düşünmen gerek. Bunu söyledik zaten. Standard library functions for files, for block input, file positioning, system file status. So these bottom ones. Fread area, memory area, size of integer, how many, from where, and data. For example, while items read, fread, integer array, size of integer, 3 of them from the spint file. As you see, we have not equals to 0 here. So it means, can we read it? If we can't, while loop exits. So it reads student by student for each record. Size of stu, 1 student. Stu is the structure. Yeah. 3 of them is red. When we write, it is written from here to the right. So new one comes here. Right? It is placed here, and the file pointer, end of file, is moved. It's a whole block. If you know the size of the structure, you can move back and forth. There is a rewind. Where is it? There is a rewind keyword. When you rewind, the file pointer, it's like a tape, comes back to the beginning of the file. So you can start reading again. And you can, this is the most, did you use this? Yeah, the seek was important. You multiply where you want, you multiply the size of the structure with the number of item, so you can immediately position yourself to the correct place with the file seek. So that is the most advanced command and thing that you can do in C programming language with files. Reposition the file with computation. That's it, basically. Seek is the most advanced one. Okay. So we'll make a quiz. How many of you didn't get the quiz? Okay. Okay, Tom. Any questions?